Hello people, this is the Science Genie once again with you lovely people to do now the IUPAC naming of these molecules. So let's first start with these steps, write them down somewhere. So number one, when you are naming your organic compounds, you need to you need to choose the longest continuous chain of carbons. Then now, you must note that never cram, right? Never cram that when you see a CH3 or a CH2, CH3, and then these guys that they are branches. No. Yes, sometimes you're going to see that, okay, if you have a CH3 and a CH2, CH3, then those guys will be branches, but it's not always going to be the case. Then, number two, you have to identify your substituents. So, your substituents that you are going to have, it's going to be your methyl, it's going to be your ethyl, it's going to be your bromo, your chloro, your fluoro, iodo, right? So now you know that your methyl and ethyl, those are going to be your side chains. So basically how a methyl looks, as you see here, you have a CH3, but then your methyl and ethyl, they come from the alkyl group. So basically alkyl group is just alkane missing one hydrogen. So then now if you are gonna have this as your methane, so if you have this as methane, basically now if you take one hydrogen and then you remove it from there, it's no longer methane but it becomes methyl. So same thing goes for your ethyl, and then yeah, for some other molecule can have propyl and whatever when your chain is very long, right? So now here, the third one, you have to say that you number closest to the functional group. Guys, this is the golden one. You number closest to your functional group. Let us remember, for your functional groups, you can have what? You can have a functional group being carbonyl group, you can have a carboxyl group, you can have a formyl group, you can have a hydroxyl group. Then you can consider your double bond and your triple bond as functional groups, but then remembering again that we are not taking your halogens as functional groups, guys. So then now your halogens and your side chains in this bracket, as it is like this, these guys, they are gonna be treated the same. No one is getting special treatment over there. So then we go to the third one. The third one is saying that if you can't decide where to start numbering, you number from the side of the molecule that is more substituted over there. So now you will see that when we do some other molecules whereby you have to now start numbering from the side of the molecule that is more substituted. So those are just the basic rules. And then when it comes to IUPAC naming, IUPAC names have three different parts. So we have the prefix, we have the parent, sometimes we call it the root, and then now you have the suffix, right? So then those were covered in the other video. So now we have this molecule over here. It has what? It has one carbon. So one carbon, if you have to remember, it is meth. And then here, this carbon is just alone. So then, and it's filled up with hydrogen. So it is from the alkane group. You can even check from the general formula. It is CnH2n plus 2, whereby there is one carbon. If you substitute 1, it becomes 2 times 1 plus 2, then it becomes CH4. So now, this name here, we do not have a prefix, because in the prefix, it will be where you're going to be having your substituents, your side chain, and whatever. So now, here in the parent, we're going to say what? Meth, right? And then between letter and letter, we do not have anything, we just join letters. So you can just say methane, because for alkane the suffix is A and E. And then we have this second one over here. So this second one, we see that we have two carbons now, but between those two carbons there is one bond, telling us that this is an alkane. So now, how many carbons do we have in that alkane? 2, and 2 is eth. So then this is going to be eth, and then we can just put in the suffix over there, which is A and E. And then now we have this one, So this one has 3 carbons. You only have single bonds between carbon and carbon atoms. So it is an alkane. And then how many carbons does it have? It's 1, 2, 3. So then it is going to be prop, right? So we must remember again, guys. Notice that this meth, eth, and this prop, they are not written as methane, butane, propane. No, basically what is going to be happening is that in your alkanes, your alkenes, your alkynes, and haloalkanes, you just write them as it is. If you do not know those rules, just go to the previous videos that we have posted. So now, here you can just put in your name, your suffix over here, which is A and E. And then we go to this molecule. Haha. Now things start get more fascinating. So here, this is when now you have to check your longest continuous chain. So let's try to connect the longest continuous chain of carbons. So then we can start and say 1, 2, 3, 4, 5, 6. And then we can have another one whereby now we say what? 1, 2, 3, 4, 5, 6, 7. So it means that this red one over here, the one highlighted in red, is not considered basically. So we do not consider this one, but we consider the blue one. So now, then, when we consider the blue one, now we can see that, okay, this is going to be our main chain. So since this becomes our main chain, the second rule was to identify your substituent. So we see that this carbon over here, it is bonded to this guy over here. And what do we call that guy? That is a methyl. So basically, when you are going to name, guys, on your molecules, what you're going to do for me, you're gonna circle the substituent or the side chain just like this, and then you are just going to write its name. So here you've got a methyl, and then now let's check where we start numbering from. Do we start numbering from the left or do we start numbering from the right? Your alkane basically does not have a direct functional group that we can start numbering closest from. So then now it means that we depend on our substituents and branches. So if this molecule was to be written as a straight chain molecule, so it would have what? 1, 2, 3, 4, 5, 6, and 7 carbons. Then here we see this carbon here does not have a substituent. This carbon does not have a substituent. The third one has a substituent, which is the CH3 that we see over there. And then now the rest of the molecule doesn't have your substituents. It's just filled with your hydrogens over there. So for now, I'm not going to put these hydrogens, but the main thing is this. We have 7 carbons over here. So since we have 7 carbons, when you say when you check from the left hand side, right? From the left hand side, you can have what? 3 carbons like this. From the right hand side, you can have 3 carbons like this, meaning that there will be a carbon in the middle. So these are an odd number of carbons. So basically, if you have an odd number of carbons, find the carbon in the middle, and then that is the one that's going to direct you to how you are going to name your molecule. So now, on this molecule, we have what? We have the left hand side now, and we have the right hand side. So from here, what you just do for me, you are going to do it on your scrap paper. You cut this molecule in half. This is going to be your left hand side of the molecule. This is going to be the right hand side of the molecule. So we see that from this side going to the right, we are not substituted. But then from this side to the left, we do have a visitor, which is a substituent. So then we start numbering from the left, in which it would be this carbon over here. I hope people understand what is happening over there. So then let us start naming over there. So we start numbering now. So we start numbering 1, 2, 3, 4, 5, 6, and 7. And then now, when we've numbered like this, it tells you now which carbon this methyl is. So you're going to say 3-methyl, and then after that, what are you going to do? You start naming. So now, as we said, your IUPAC name has what? Has 3 parts. So it has your prefix, your parent and your suffix. So we're gonna start with your prefix, which is your part where you have your substituents. So the only substituent here we have is our 3-methyl, guys. So this is one thing that you have to consider. Between a number and a letter, you're going to have this dash, or some would say hyphen, but that is to your preference, guys. And then we go to the parent or the root. So the parent has how many carbons? It has 7, and 7 is hept. 7 is hept. And then now, after that, what are we going to say? This has single bonds between carbon and carbons in the parent chain. So it means that the suffix of this molecule is going to be ANE. Right. And then let's move to the next molecule. You can pause the video and try to do it yourself. So now, when we are naming this molecule, you are gonna start and check which one is your longest chain of carbons. So then we have what? 1, 2, 3, 4, 5, 6. And then now you can check again. So you can say now 1, 2, 3, 4, 5, 6. So both the blue and red is fine, but then now you see that the blue one is the straight chain and it makes our life more simple. So now, guys, then what do you do now? You are going to identify your substituents. So now, as you identify your substituents, there's an H missing, guys, over here. Let me just put it. Be careful of that also. So then now, as we check here, we have this guy over here, which is our visitor, our side chain. This side chain's name has 1 carbon, so we say that is a methyl. And then now, where are we going to start numbering? So here, you see that we had 6 of the carbons in the parent chain. So then now, obviously, we can split this molecule in half like this. And then we see that the right-hand side is the one that is substituted. So then we start numbering closest to that branch. So we say 1, 2, 3, 4, 5, and then we're gonna say 6. Then after saying that, we're going to start numbering. So we start with our prefix. Our prefix is going to be here 2-methyl. So this methyl is on the second carbon. So we say 2-methyl. And then now we are going to say how many carbons do you have in your parent chain? 6. And 6 is hex. And then now which homologous series? So which homologous series? It is going to be what? An alkane. So it's going to be alkane. Right. And then let's move to the next molecule, guys. So I now trust you with these molecules. I know you guys are killing it now. So for these 2 molecules that we have here, you can also try and go ahead and try it for yourself. So now, as we have this molecule, we still apply the same rules that we have been applying. So now we're gonna say we choose the longest continuous chain of carbons. So our longest continuous chain of carbons here, it's 1, 2, 3, 4, 5, 6. And then if we do it again, I believe you can see it is just like this molecule there at the top, but then this methyl is here at the bottom. So now with all of those things that we're gonna have here, we can start numbering and say 1, 2, 3, 4, 5, and then you say 6. And then this guy again will still be what? 2-methyl, guys. It will be 2-methyl. Then the name is just like the one at the top, which is your 2-methyl hexane. I hope you got that one. And then now we have this molecule here. So this molecule has a condensed structure. So with this condensed structure, now we are going to say that this carbon and this carbon are connected. This carbon over here and this one are still connected, just like now when you are going to check it like this. So you can say that safely this carbon, and this carbon are connected. So you can choose basically, but then now the simplest thing to do in this type of molecules, you're going to do what? You're going to take this molecule and write into its structural formula. So now you're going to say 1, 2, 3. So we're gonna start with this one, CH3, and then we're gonna go to the middle carbon, and then we're gonna say C. This middle carbon has a hydrogen connected like this, and then it has a CH3 at the bottom. So now this is going to be CH3 like this, and then now we have this last one over here, so you're gonna say C123, so like this, and then you just fill in your hydrogens over there. Guys, remember to fill in all your hydrogens and your bonds, because you will be penalized if you miss even one of those guys. So now let us start then. So I believe you can see that the longest chain here, be it we choose this one that is bent, or even if we choose this one that is straight, basically, now you can see that both of those guys will have 3 carbons in the main chain. So now when we do that, you can start numbering from either side here, because now you can see that it has 3 carbons, and then on the second one we have a methyl. So you can say 1, 2, 3, and then we know we have some people who would love to number from the right, people who are always right. So now then we are going to say that here we have a methyl, so this is a methyl, but then it is on a 2, it is on the second carbon, so it's 2-methyl. Then now what are we going to say? Going to say that this is 2-methyl, 2-methyl, 3 carbons is prop, so it is prop, and then the suffix here, it is going to be ane, because this is alkane. So now that's basically how you would do it when it comes to your alkanes. Alkanes are very simple to name, guys. Please do not complicate it. So go with me as we go do the alkenes in the next video. Thank you.